Hello and welcome to this video where we're going to look at ARP. Now here's another acronym for you. ARP stands for the Address Resolution Protocol. So as you can probably guess from the name, it's a protocol. So we mean it's some standard thing that we've agreed upon how it works, and logic's been implemented in the computer so that it can do this function, this protocol. And what this protocol does is that it resolves an address. Now, what address does it resolve? Well, as I've written here, just a basic description of ARP. It discovers the MAC given the IP. So the protocol that we're trying to resolve, or the address that we're trying to resolve, is the MAC address. We know the IP, but here's a question you probably got instantly. How would you know the IP? Right? Well, maybe DNS, right? If you go into your web browser and type google.com, right? And you go and press return, your computer would go and do a DNS request and find the actual IP address that's associated with that, because at the end of the day it's all IP addresses. So maybe this protocol is being used to discover the IP. Maybe you know it, right? If you're doing a simple, I'll make a video on this. If you're doing a simple ICMP ping, then you as the person would type in the address and then it would be known that way. So it depends on how the IP address gets discovered. But the idea is that we somehow know that. Then what we need to do is discover the MAC. That's what ARP does. Okay, so the messages that ARP use is a request and a reply. Now these terms might be unfamiliar to you, broadcast and unicast. I'll explain that now before we get into anything else. There's three main types of a way that we're going to send traffic throughout a network, in networking. So there's unicast, broadcast, I'll just shorten that, and then multicast. There's technically anycast, but I won't get into that in this video. So these are the different ways we're going to that the packets are going to traverse the network. Unicast, and I'll draw little diagrams here. If we've got some host and we want to send it to some other host, packets or traffic, we want to send stuff to the other host. Unicast is simply just one-to-one, right? 1 to 1, right? Whether it's there or whether it's here, and then maybe back, or this computer, it's just one source and destination, one-to-one, right? Broadcast is one to all. So here's the source and here are the different destinations. Broadcast goes to everyone, right? And this is sort of an efficiency technique. These two are sort of used more for efficiency, and the reason is that the sending host doesn't actually have to, like in Unicast, if you wanted to send stuff to all four of these computers, you'd have to generate one packet, another one, and another one. With broadcast, the actual switch or the router in the middle, or generally the switch, will actually take in one request and then replicate it for everyone else. So it's like an efficiency technique, but it's like a radio station broadcasting out. Everyone in that space will see it. So everyone in this network will see a broadcast. So one to all. Multicast is sort of in between. It's one to many, but it depends on who actually wants to see it. So multicast is a complex topic, but it's sort of like this host decided they wanted, and this one decided they wanted to receive it. Then the source sends one packet, and the switch actually gets it just to those people. So it's one to people who have subscribed to say, I want to get this traffic. Okay, so I'm not going to get into more detail than that, but one to many, multicast, one to all, broadcast, and one to one, unicast. So this is an important concept to understand, and I thought I'd introduce it in this video. So when we look at the types of messages in ARP, the request, which is saying, I know your IP, I want to know your MAC, I'm requesting your MAC, that is broadcast. So I've drawn in this little network, we've got 4 computers, each with their IP and their MAC. Keep in mind these addresses aren't real IPs or MACs, they're just simplified for this example. and this computer wants to send something to the server, and it knows its IP address. Okay, maybe we did a ping and physically, we typed ping.3. Okay, so somehow we know the IP address, but we don't know the MAC address. We always need to, when we're sending a packet, have some source, destination, and IP, and then some destination, IP and MAC, right? Or sorry, some source IP and MAC and some destination IP and MAC. We know the destination IP, but we need to know the destination MAC. So we send the ARP request, right? Here's the ARP request, right? It's this color, and it comes into the switch, and it gets broadcasted out to everyone. That makes sense, right? We don't know the MAC, so we're just going to say everyone who has the MAC address that's IP address is .3, broadcast. Now, .3 gets this, and it sends an ARP reply. Now, this is Unicast. It's just 1-to-1, right? It would know, because you always attach a source when you send something, this computer then would know how to get it back to the source because that was listed in the packet. So the request gets sent to everyone, and the person that has it sends back the reply. And the reply says, yeah, I'm C. Then you can start sending your packets, and we can do whatever we want to do, transfer a file or stream some movies. Maybe this is a home movie server. Okay, so that's the theory. Let's look now at Wireshark. Okay, now I haven't even captured an ARP yet, but if we go on this network and sniff, well, we'll see one soon enough. Right? But I'll speed it up a bit, and I will open up a command line here. Now, I don't want to confuse anyone. I'm using a protocol that simply tests connectivity. Okay, and I'm going to ping some address on my network. Okay, I'll get into the details of this protocol, but I'm pinging an address right now, right? We know what the destination IP is. I just typed it in. We're going to need to know the destination MAC if we're going to ping that device. This device doesn't actually exist. So when we send this, we'll see on Wireshark, we'll get a bunch of requests, but we won't get a reply. So I'll press enter, and we see, look at that, as soon as I did that, ARP kicks in the background. Let's stop this. And we see that here is an ARP request. It's broadcast, and the actual MAC address when you send a broadcast is all Fs. Okay, and it's going to everyone saying who has .100, right? That's the destination. Tell .9, which is this computer. So if we actually look at the ARP protocol here, we see that here's the source IP and the source MAC. The destination IP we know, but we don't know the destination MAC. Look at that, it's all zeros. So this is requesting who has this. Now, if this computer actually existed on my network, it would send an ARP reply. Okay, now let's find an ARP reply. Let's start this again, and there'll be applications running in the background on my computer, and soon enough we'll see an ARP request and a reply, even if I'm not, manually pinging. So let's just wait, and in a second we should see an ARP. Look at that. It happens a lot, right? I didn't even have to, cut this video to find this. So here, now this might be a bit confusing. Okay, well, we'll just look at the reply because we've seen a request. Okay, this is some other address we were requesting, and here's the reply, right? And then it's telling us, right? In the other one, in the other example, this was all zeros, but now when the reply comes back, it's telling us who the destination, who the MAC, what the MAC is for the destination. Sometimes the request is not is not broadcast. In this case, this request, the destination isn't all Fs, which is broadcast, and this is sort of confusing, but for this example, just know that the request is broadcast and the reply is unicast. But in this case, my computer actually knew the destination. This is my router, and it was actually just sending some sort of, keep alive, just saying, hey, I'm just checking again. And because it actually knew, it just unicasted it to it. But generally, it will be broadcast. Okay, so I hope this example just sort of gave you the idea that we've got these two message types that we're sending with ARP. Okay, so I hope this video was useful for you, and maybe if you already knew about this protocol, it cleared up the misconception I used to get confused about. How do you know the IP? If you don't know the MAC, how do you know the IP? And well, it really comes down to the application, right? In this case, I typed it in. Maybe you're using web browsing and you're using DNS. It just depends on the application. But this is what ARP does. So I hope the video was useful for you, and thank you very much for watching.